A small blue dot on your phone knows where you are. But it was not invented for road trips. It was born from fear, from submarines hiding under the ocean, from missiles, clocks, satellites, and one military question. How do you find your exact position when the world is dark, moving, and dangerous? Long before satellites, navigation was a fight against uncertainty. Ancient sailors watched the stars. Desert travelers followed the sun, wind, and landmarks. At sea, a cloudy night could turn confidence into panic. A ship could be only a few degrees wrong and still miss land completely. The problem was simple. For centuries, sailors could estimate latitude by looking at the sun and stars. Longitude was the nightmare. To know east or west, they needed time. Not rough time, precise time. A clock on a ship had to survive salt, storms, heat, cold, and endless movement. Before accurate sea clocks, many sailors were not just traveling across oceans, they were gambling with the map. By the 20th century, navigation had better tools. Radio beacons, radar, charts, and inertial systems helped ships and aircraft move with more confidence. But every system had a weakness. Radio signals could be blocked, bent, or limited by distance. Inertial systems drifted over time. A submarine under the ocean could not simply ask the sky where it was. The military needed something global, silent, reliable, and available even when the weather was terrible.
Signal steady. It's moving. It's clearing the horizon. Still no identification. Keep monitoring. This is history.
Then, in 1957, the Soviet Union launched Sputnik. To the world, it was a shock. To scientists listening on the ground, it was also a strange signal in the night. As Sputnik moved across the sky, its radio tone shifted. This was the Doppler effect. The pitch changed because the satellite was moving toward Earth stations, then away from them. The first major answer was transit. It was built for a very specific military need. The United States Navy needed its missile submarines to know their position. These submarines could hide under the ocean, but they still needed accurate fixes. Transit used satellites and Doppler shifts to help ships and submarines calculate location. It worked, but not instantly. A submarine might have to wait for a satellite pass, and the fix could take minutes. For the Cold War, that was useful, but it was not enough. Transit proved that satellites could guide machines on Earth, but war does not wait politely for a satellite to pass overhead. Aircraft move fast, ships drift, ground forces cross unknown terrain. Missiles need timing and position with terrifying precision. The military wanted more than occasional location fixes. It wanted continuous position, velocity, and time, anywhere on Earth, in any weather, day or night. The next breakthrough was not just about location, it was about time. At the Naval Research Laboratory, Roger Easton and his team worked on TIMATION, short for time navigation. The idea was powerful. Put an accurate time signal in space. If a receiver could measure how long a signal took to arrive, it could calculate distance from the satellite. With enough satellites, distance could become position. This was the hidden truth of GPS. It is not only a map system, it is a clock system. There was no single magical inventor of GPS. That is the honest version. Different military branches had different ideas. The Navy had transit and TIMATION. The Air Force developed Project 621B. Other work also helped shape the system. In 1973, Defense Department planners began combining the strongest parts into one navigation system. The goal was bold: satellites in medium Earth orbit, atomic clocks, ground control stations, and receivers that could calculate position from timed signals. The name became NAVSTAR Global Positioning System. A concept is not enough. The system had to be tested in the real sky. In the late 1970s, the first experimental NAVSTAR GPS satellites began launching. Engineers tested the satellites, the ground control network, and the user receivers as one machine. The challenge was brutal because every part depended on every other part. A tiny timing error could become a large position error. The dream was simple to say, but hard to build. A user on Earth receives signals from several satellites, and the receiver solves its own position. GPS was built for the military, but the world outside the military was changing too. Airliners crossed borders every day. Ships moved through crowded routes. People needed safer navigation, not only stronger weapons. In 1983, after the destruction of Korean Airlines Flight 007, the United States announced that GPS would be made available for civilian aircraft when the system became operational. It did not mean everyone instantly had perfect GPS in their pocket. That came later. But the idea had changed forever. A military system was starting to become a public safety system. For years, civilian GPS was useful, but limited. The military kept the most accurate service protected. A feature called selective availability intentionally reduced the accuracy of the public signal. This was done for national security. The fear was clear. If civilians could use precise GPS, enemies could use it too. So the world had a strange situation. The satellites were powerful enough to guide with great accuracy, but civilian users were forced to accept a weaker version. Then came a quiet turning point. In May 2000, selective availability was turned off. Civilian GPS became far more accurate overnight. Cars could know which road they were on. Surveyors, pilots, farmers, hikers, ships, emergency teams, and delivery networks gained a stronger tool. The blue dot became trustworthy. And slowly, GPS moved from military receivers into cars, phones, cameras, watches, and machines all over the planet. Today, GPS is not just about finding a restaurant. It helps ships cross oceans. It helps aircraft navigate routes. It helps emergency crews reach people faster. It supports farming, construction, science, mapping, and delivery networks. But its most invisible power is time. GPS timing helps synchronize systems that need to agree on the same moment. The invention that began as a military answer became part of the hidden rhythm of modern life. So the next time that blue dot moves on your screen, remember what it really is. It is not just a feature. It is an echo of ships lost at sea, clocks fighting storms, submarines hiding in silence, and scientists listening to a satellite beep in the night. GPS was invented because the military needed certainty in a world where being lost could change history. But the solution escaped the battlefield. It became a quiet guide for everyone. A tiny dot powered by atomic clocks in space, telling humanity the same ancient answer. You are here. The blue dot began as a military secret and became a quiet guide for the world. If you enjoyed the story, like, share, and subscribe.